Hello guys, I am Taranpreet Singh. I completed my BCA this year and today we'll be solving this problem called prefix as a substring. Its problem code is a tongue twister for me. It is SSTRPREF. Its difficulty would be medium and it requires Z function or hashing and readme structure in order to solve it. So let's begin. The problem statement is something like this. We have these three strings S1, S2 and X. What we want to do is we want to count the number of non-empty substring of this third string X such that it satisfies this condition. The condition is we choose a prefix of this string S1, a prefix of this string S2, we concatenate them and we can get the substring. Let's just consider an example here. Let's say S1 is something like this, A, S2 is B, C, and let's just, we want to check whether this string R is a good string or not, whether we can represent it this way or not. So what are the choices we have for P? P can either be empty string, let's say we represent it by something this simple. We can either choose it as A and then AB. Like these are all choices we have for P. What are the choices for Q? It would be something like empty string, then B, then BC. We chose a prefix. So can we write R as like we choose one of these and one of these and join them? In this case, we can actually see that we can pick uh, P equals to A and Q equals to BC, then we get ABC. So R is a good string. We want to count the number of good strings which appear as substring of X. One more thing I would like to highlight here. Let's just remove this C here. Okay. So what right now we can just see that we can either choose P equals to A and Q equals to B to get AB. Or what we can do, we can choose P to be equals to AB and choose Q to be empty string. We get this string R in both ways. So we don't count it at two times. We only count it one time. That is one thing. So I hope the problem statement is clear. So we'll begin with the solution then. All right. In most problem involving substrings, like whether when we need to count the number of goods or bad substrings, it's usually good idea to see what this thing implies. Like let's just say that a substring from L to R is good. Just based on this information, what can we say about substrings like these? Like moving one character, the right end to be either left or right, or left hand to be left or right. What can we say about those strings just based on this information, nothing else? Let's just say that P is something like this. P is from 1 to 2 and Q is like, if it is good string, then we are assuming this thing, right? Moving left and one step to the back, like if we know that this substring from 1 to 5 is good, can we say something about 0 to 5? Well, it's tricky to say because this correct we would kind of need to see the whether this thing matches with the prefix of P or like S1 or S2. It's kind of like it may happen, it may not happen. So we would just say we cannot say anything. If it is not good, even then, let's just say we take an example. S1 may be something like A, B, C, and S2 may be D, E, F. So we may have A, B, C, D, E, F. So even though this one was not good, this one turned out to be good. But it may also happen there might be some unique character here. So we just cannot say anything here. Similar thing maybe happens for this one because let's just see based on this information we cannot just say, let's just say that this one is whole thing is good. We couldn't just say that this one is good as well. Similar thing happens in this scenario. Like moving the left hand in this problem is quite tricky because we would need to make sure that whole prefix matches again. Moving the right hand might be a bit easier. Let's just see now. Like in these two things, we are moving right hand one step. Now this one asks us, like, now we can just assume, I'll just clear out this useless information for now. We have this information. Based on the information that substring from 1 to 5 is good, can we say that substring 1 to 4 is good or not? Let's just pick A, B, C, D. Can we say that substring 1 to 4 is good? I think we can. Like, let's just say that we chose P equals to A and Q equals to B, C, D. Or maybe A equals to A, B and B equals to C, D. We can just always choose one smaller prefix. Like if BC is a valid choice for Q, then we can always choose Q equals to BC, and we would get a substring which is one smaller than the substring we already chose. So if we can say that from L to R it is good, then we can definitely say that substring from L to R minus 1 would be good as well, because only then we are able to kind of like, if we didn't have this whole substring good, if we have the whole string good, we can always remove one character from Q or P. If Q is empty, then we would get a valid string, right? Now what they ask us to do is, if this whole string is not good, can we say that this string is good or not? What would happen if we had something like, let's say, F here? I'll just put a F in place of E. If we had a F here, this string may be good, may not be good. Like this character may be something which is quite unique. It is already not good. It may be because of these character, like this character is unique. We cannot say anything by surety. Like if it is not good, a smaller substring may be good, smaller substring may or may not be good, right? Now once again we are assuming that string L to R is good. Can we say, like, can we extend it by one character? Even in that situation, the next character may be some character which does not appear in string, or it may be something which is already appearing in S2. So we cannot just say anything by surety. But last thing, if we have this substring from L to R to be good, can we just include to be not good? We cannot just extend it. Like we know that if we have this substring is good. If this substring was good, we could say that this one was good as well based on this condition, because like this for this substring, if we move right and one step back, we would get this string. So if this one is good, then this one would be good as well. But we are assuming that this one is not good, so this one must not be good as well. I know this was a bit tricky, like these cases are usually helpful in a general scenario. So what can we say about this problem here? Let's solve this problem with one string now. We will use this observation that for each left endpoint, we try to find the largest right endpoint such that this is a valid, this is a good string. So let's just modify this definition. For each left endpoint, we try to find the smallest right endpoint so that this is not a good substring. Like it's just a minor modification here. Like it would make a bit easier in case this string itself is not valid. We would kind of need to, the R would go behind. So we are just making an adjustment here. For each left point, we are looking for the smallest right endpoint such that this substring is not good, right? It would be something like if this substring is good, like in our previous example 1 comma 3 was the largest substring was good. So what we do is 1 comma 4 was not good, so f of 1 we represent by 4. This function I'm just using for representation, right? Okay, let me just erase this. So what happens after that? We need to compute for each position how many characters we can pick. Like for each position in X, we need to see how many characters in X we in S1 we can pick which are prefix. Like let's just say something like this. For each position, like this is X. So for this, like for this position, we compute this quantity. Let's say this thing matches with prefix of S1. So this will have Z array, like it will have something like 2 computed here. It is quite similar to what Z array does. Like Z function is a well-known data structure. What it does is it accepts a string S, Z. Okay, I'll just move that one. Z function, it accepts a string S and returns for each position the number of characters starting from that position that can be picked which matches the prefix of that string only. Something like this. I will just. So what we have is, let's just say that S1 is this string ABC and X is this string ABC, ACAB. Like this thing I added for just to handle some edge cases. Just add any random character which does not appear in string. So what we do is we made a string T which is S1 concatenation of X. Why we did this? Because Z function normally picks the prefix of its own string it is considering, right? So in this string, what it would mean? Let's just say Z array computes for this position. It will check the number of characters which can be picked this point onward which match with the prefix here, right? So for this position it would be 3. The Z array I have already written here. Like from this position we can pick 3 characters. That way this provides us an easy way to kind of compute the function values. Function asks us to compute the position. Right now we know from each left endpoint how many characters we can pick. So it would be just Z of I plus I, something like this. So like F would come out to be something like, and by the way, we do not care about these positions. Okay, there should be one more 0 here. We do not care about these positions here. Like these are the ones which are kind of part of this S1 and we only care about the number of characters we can pick for correct positions which are in X. So function would come out to be something like 3 plus 0. Like for position 0, it should be position of this string like 0, 1, 2, 3. It will be 3. For B string, we cannot pick any character, so its own position. For C as well, we cannot pick any character. For again A, we can pick but only one character, so it would be 3 plus 1, 4. What am I doing here is for each position, f of I equals to z of I plus I. We know the number of characters we can pick from this point onward. We know the start point, we can just add it and compute the endpoint, right? Once again, I have 4, then I think, I'm not sure, 6, it should be 0, 1, 2, 3, 4, 5 plus 2, it should be 7, and 6 plus 0, it should be 6. So this way, we have solved this problem for one string. Like we can now just compute that like we can compute summation f of I minus I for each character, and this sum would give us the number of substrings, right? So let's move on to two substrings now. For two strings, let us consider an example now. I'm just taking the example from problem statement. I think it is third example. So what I have done here is strings s1 and s2, x from the sample, and I computed the f function which we talked before for both of the strings. Like for s1 it is this one, like for position 2, let's just see position 2, we can pick these whole, but the fifth position is the first one which cannot be picked, right? So what we did for f2, we represented it to be position of first position, we couldn't include it in the substring, right? I hope till here it is clear. Now what we are going to do, for let's just say I'm considering the start point to be 2. I can either choose it to be something like I chose no character, and then I would be able to extend it till using second string. I would be able to cover it till here, only this one. That is one way. Or what I can either choose the string this one, then I would be able to cover it till here, right? So the substring covered would be p plus q would be something like up to position 4. Position 4 not included, position 2 and position 3. Or I may do something like this. I choose this thing, and then I am not able to choose anything, like q would be empty string. Again, I'm able to pick this. Or what I do is I just pick this whole thing. See, on this way, the start point is this. We need to find the largest number of characters we can pick from this position, so that we only pick, it matches the prefix of s2. This we have already computed, so we can just pick here. So what we got here, for position 2, we were able to pick 2 to 4 as p, and q to be 5 to 7. So what number of substrings, like we now, I can assure you there, as we did refer to our observation 1, we can always choose this to be like something like this. Now we are able to pick the substring from 2 to 6. If we pick till here, then we are able to pick 2 to 5. 2 to 4 is also possible, 2 to 3, 2 to 1, 2 to 2, sorry, right? This way, we just, for each position, we just need to find the rightmost position which is valid. But for two strings case, what it happens is we can choose any start point which is not which is from this start point L till where we can, if we can reach position X as the first non-excluded point, so we can choose any start point in range I f1I. This is the important point here. In this case, what we were able to do, we could choose for second string, we had to pick either from here and find the maximum from here. If we chose the first string to be just a single character, then from here, if we choose first string p to be up to 2 characters, then from here, or if we choose whole thing, then up from here. So what we had to do is we had to consider 4 cases here, 3, 4, 4, 8. Wait, there is some issue. Okay, right? Among these, we can choose the one which gives us the maximum length, because as the length will increase, the rightmost position will move to the right and the number of substrings will increase, kind of. Like we want to count the number of substrings, and if it is possible, we just care about any one way, right? In this case, this range would be 2 comma 5. So what we can do, consider this range, choose any start point such that the right end is maximum. So what we can do, we just pick the maximum of this range. We get for start point 2, we were able to get the largest right end, which is we cannot achieve a substring total p plus q combination which will include position 8, but we can obtain till 7. I would, let's say, call it the best value. Like, we are now combining these two smaller problems into one thing. Choose first from these positions 2, 3, 4, 5, and then continue from next position till and maximum how much we can pick. So what we can do, we can just kind of implement a range maximum thing on this thing, because for this interval we just needed the largest position, and it would just compute the maximum the smallest right position till where we cannot include. Like for this one, we can pick this thing as a good substring, but we cannot pick this thing, right? This solves the problem for us. We would need to compute this range maximum thing for each position. I just demonstrated it for position start point 2. Let's just take another example. Let me just erase this. I'll just keep this thing. Erase rest. Okay. So let's just consider this position. Start point to be okay. Let's just say the start point is this. We can pick either 0 character or 1 character. In that case, what happens is we can either choose from this range. If we pick 0 characters, then we would be able to pick the whole thing. We can choose P to be empty and Q to be ACB. Once again, we just need to compute the maximum of these two, like the rightmost position we can make substring, which is a good one, right? So I'll just remove these extra strings now again. So this is a best array I have already computed. Wait, I think there is some issue. I'll just correct it. Yeah. So this is the best array we have already computed. For position 0, I could just pick no character from there. So only choice for P was empty string, and for that one, I just picked this maximum. For position 1 as well, this maximum. For position 2, I can pick maximum of these. It is 8. For position 4, I could pick only these two positions, and maximum of 4 and 4, it is just 4. For position this one, once again I could just pick this one, simply this. Position 0, 1, 2, 3, 4, 5. For position 5, what I can do, I can pick maximum of these two. It is 8, so I just put it 8 here. For position 6, I can just pick maximum of this thing, so it is 6. For position 7, once again, I can pick 7, 8, and 9. So this way we have solved the problem. Now we just need to compute summation of best of I minus I. So this solves the problem for now. In order to compute the range maximum, we can use segment tree or sparse table as well, because the array once computed does not change. So let's jump into the code. I hope the problem is clear. The code starts something like this. We have 3 strings in input. I just read S1, S2, and X. And I just append this character just to make things easier, as I mentioned in video. I compute the length, and then this is the I just make calls to a function I created, which computes the z array, which I'll show later. I added a extra character because what may happen is the start of x may also be some. It just helps to break there, like we don't accidentally pick any character from x. We compute the z array for s2 as well, and then as I mentioned, the first uh, characters which do not belong to x, those does not matter to us, right? So I just remove those ones, and then from going from the number of characters we pick from the prefix to the rightmost position, we just add I, as we did while computing fi from the z function, right? Now what we are left with, we need to kind of compute the range maximum of second array. So I just update for each position, I just place the value of f2 there, and then I have this answer variable for now. This I represents the left endpoint. For I just computed the range maximum considering the range from I to f1 of I. That range, the one which we were taking maximum, and then it just gave me the right end, which is the smallest right end for which the substring is not possible. I just added this to the answer. Now only thing left is the computation of z array. Segment tree I am assuming you are already comfortable with, and this is kind of a template code. You can actually refer this one, I think, at cpalgorithms.com. They have a very good resource. I'll just type here. There should be a page for z function. So let's submit this one. I have copied the code, submitting here. I actually have the the CP algorithm site. I have it open. I'll just paste that one here. In comments, it would be easier to refer. Right? I'll just copy the code here and submit. By the way, one thing I would like to mention, the way we did it for two strings, we can actually extend it to multiple strings as well. Like we compute for first string, we just took the range maximum and computed the best array. Let's say there were strings s1, s2, and s3. We could do the same for s2 and s3, get the best array, and take range maximums again, like computing the z function of first string. It is a good exercise. We can just have a problem, something like there are m strings, and for each string we can pick one prefix from this to this, and then for one prefix. Okay. I guess that's it for today. I hope you guys had fun and managed to solve this problem.